This video is the second in a series of videos on transformations. This one is on reflections. So a reflected image is just a mirror image of a pre-image, and they are isometries, which just means that the pre-image and image are congruent. And so we call that mirror line the line of reflection. And it's a flip of the pre-image. That's kind of the casual word for reflection. Sometimes we call them flips. You can have a line of reflection over any line. For our purposes, we're going to demonstrate reflections if you're reflecting over the x-axis, the y-axis, over the line y equals x or y equals negative x, and any other horizontal or vertical lines. Again, you can do it over any line, but that's the only ones we're going to talk about. Here's reflecting over the x-axis. Here's our x-axis. If you think about the plane as being something you could fold, you would think of the x-axis right here as your fold line, and then whatever is on one side, your pre-image, would be exactly opposite, as a mirror image would be on the opposite side. You can tell who your pre-image is by the way the points are labeled. These are just A, B, and C, so that's your pre-image. So I like to think about it as if I took some ink and I just kind of colored all that in, and then when I folded, it's the image that would show up from that fold. The ink would go onto the other side. And I know this is the image because it says A prime, B prime, C prime. So we have rules to help us do this. Now I know we can see it. And basically what you could do is you could say, okay, here is my line of reflection. Pick any point you want and see how far away it is from that line of reflection. And then go on the opposite side of that line that same amount, and you will get the image point. Over here, my C is 2 units away. I go to that line of reflection and go 2 in the opposite direction. So you can do that, but you can also just think of the mapping. Any XY in your pre-image, if you want to find that location after reflection over the x-axis, well, that x value stays exactly the same, but you take the opposite value of the y value. And so the negative y means take the opposite. If y is a positive number like 2, this would become negative 2. But if your y was already a negative, you would take the opposite and make it positive. If you're going over the y-axis, now this is where I'm going to fold my paper along the y-axis. Here's my triangle ABC. So if I were to ink that up and then fold the paper, I would get an image right over here. And so you can do this by, again, counting how far away you are from that line of reflection. This one, let's say A is 1, 2 away from my line of reflection. So keep going in the other direction too, and you can find the image point. You can do that, or you can use this rule right here. For every XY in your pre-image, your X becomes opposite, but your Y stays exactly the same. If you're reflecting over the line Y equals X, and this is the line Y equals X right here, if you forget how that works, if you remember y equals mx plus b, remember how that? Back in the algebra days, in this case, your m is 1 and your b will be 0. That's y equals x. So you can start at your y-intercept of 0 and then go up 1 over 1, up 1 over 1, or left 1, down 1. Just reminding you how you find y equals x. So this is my fold line. And this one it's starting to maybe be a little bit harder to see what that would look like. So again, here's my pre-image. And if I was to put some ink on there and then fold along this kind of diagonal line, you would get the image produced over here. Here's where maybe knowing these rules makes more sense, because in all the examples we've had so far, it's easy. You can just count how far away you are. But now we're kind of counting on diagonals. It doesn't work so well. The way you can do a transformation over the line y equals x is you take any pre-image point, and then you just turn the y and the x value around. Your coordinates will flip locations. And I remember this one because yx, it kind of looks like y equals x, and that helps me to remember what that actual transformation is. Now, if you're going over y equals negative x, so remember how y equals x was this one? So y equals negative x is now, it's the negative slope version of that. And so you have the diagonal going the other way. If this is my point in my pre-image, say, then it will be over here in the image of it when you do the reflection. Here are the rules, kind of like y equals x. It's still, you turn these around, they swap locations, but because there's a negative here, It reminds me that I should make them both negative. What about any other vertical or horizontal line? You could try and find some mathematical mapping. I will say for our purposes, it's probably not worth all that. What I would suggest you do is you graph that line of reflection. So if they told you, hey, the line of reflection is x equals -2, well, then go ahead and graph that. Here is the line x equals -2. And remember, x equals a constant. That's your vertical lines. And then count. So like over here is A. That's my pre-image. How far away am I from my line of reflection? 1, 2, 3 units. And then continue in the opposite direction for the same 3 units. You'll find that matching point. Here's vertex B. It's only 1 away. So B prime, just keep going 1. C is 1, 2, 3 away, go 1, 2, 3. And you can do the same thing if you have a horizontal line. So here is the line y equals 2. Remember, y equals a constant will be a horizontal line. And you can do the same kind of thing. So if here's the point that we want in your pre-image, it is 1 away from my line of reflection, so just keep going 1 in the opposite direction. You can use midpoint formulas. It's much more complicated. I would say just count the boxes. If it's on a piece of paper, you might even be able to fold it to see it. So far, here is the summary of what we've looked at. Reflecting over the x-axis, x stays the same, y becomes opposite. Reflecting over the y-axis, y stays the same and x becomes opposite. Reflecting over the line y equals x, you get something that kind of looks like y equals x. And reflecting over the line y equals -x, you kind of do what you did for y equals x. It's just they're both going to be negative because there's a negative there to remind you that's what it looks like. Other vertical or horizontal lines, just count the boxes. Got one more kind of reflection to talk about. So instead of reflecting over a line, you have a point reflection, and you basically are reflecting around a point. The way that kind of works is you pick a point, and then here is my pre-image. You figure out how far away A is from your point that you're reflecting around, and then you go that same distance. So if this was, say, x units away, you keep counting x units to go there. And for my B prime, how far away is that one? Maybe that's y units away, so keep going y units to get the B prime. If this is z units from C to P, keep going z units. And it involves using like midpoints and things like that. But for our purposes, for every point in the figure, you're just finding another point that is the same distance away from that center point. And if you look at it, this is the same as rotating a figure 180 degrees. And we're going to be looking at rotations in a different video. But if you look at what we've got here, it's like you're on a pinwheel and you just turned it all the way upside down. This will be the same as doing a rotation of 180 degrees. But we can look at the rules here. And this is, again, we're always going to be reflecting about the origin. You take your xy that you're starting with and you just negate both values. That's all you have to do. And that will turn this figure upside down as if it was twirling around the origin. We have some U-tries here. What you need to do for this one is you're going to graph that initial figure, and we can actually do that while we're here. And you're going to do 4 different reflections. Once around the x-axis, once around the y-axis, once around the value x equals -2, and once around the value y equals -1. You're also going to do a reflection here over the lines y equals x and y equals -x. Be sure to write out the rules for what those look like. And then finally, you are going to graph the reflection in the origin. Boy, that sounds weird. If you see that kind of wording, graph the reflection of ABC in the origin, that is a point reflection. About the origin. Go ahead and you can pause the video and work on these 3 things. Be sure that you are graphing the pre-images in each case, and then be very clear about how these points transform. So we are back, and let's see, x-axis. So let me write the rules down because now there's like a lot of different things. So when you are rotating about the x-axis, the x stays the same and the y becomes opposite. My A prime for that, if A is 2, 4, the x stays the same and the y becomes opposite. For B 6, 3, the x stays the same, the y becomes opposite. C prime, the x stays the same, the y's become opposite. So I can graph that first one. And here is my x-axis, right? And just picture folding it. All those points are going to line up. So that's the x-axis. Let's do a different color for the y-axis. So for the y-axis, the mapping is you have an xy. Now the x becomes opposite, but the y stays the same. So I'll call this a double prime just to differentiate from the other one. Now my x, so I've got up here 2, 4. The x becomes opposite and the y stays the same. For the second point, 6, 3, the x becomes opposite, y stays the same. And that third point, 3, 2, x becomes opposite and the y stays the same. Let's graph that. And here's my y-axis. If you were to fold along there, these points should line up. Okay, so for the other ones, x equals -2, so using a different color for that one, you're going to graph that x equals -2. And remember that x equals -2, that is the vertical line that goes through where all the x's are, -2, right? Every point on here has an x of -2. So I'm going to count carefully. So in my mind, I'm trying not to see this blue triangle sitting there. How far away is A from this orange line? It's 1, 2, 3, 4. So continue 1, 2, 3, 4. That will be what I'm going to call a double prime. So if you want to write that down, you can just read that point off, -6, 4. What's B double prime? So B, let's count how far away. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8 is over here. There's your B double prime. I'll just read it off the graph. That's -10. And then I'm going up 3. And then C, it's 1, 2, 3, 4, 5 away from that. So count 5 again. 1, 2, 3, 4, 5. And there's my C, A, B, C. And C double prime here is -7 going up 2. For y equals -1, you're going to graph this first, and y equals -1 is over here. Maybe I should use a better color. So that's y equals -1. And we're going to just count the boxes. I think that is the easiest way to deal with those. 1, 2, 3, 4, 5. Count 5 again. 1, 2, 3, 4, 5. And I'm going to call that one a triple prime. And this is for y equals -1. And that's at point 1, 2. And then we went down -6. So for B, we're 1, 2, 3, 4 away. So count 4 again. And that looks like B. And then C is 1, 2, 3. So go 1, 2, 3. And that will be the C triple prime. And that coordinate is 3. And then we went down, look, -4. And I think that's the easiest way to handle that. This one, we're going to graph this particular pre-image. And let's graph that one first. So I've got a triangle over here. And I'm going to do 2 reflections, one over the line y equals x. So y equals x. I'm just going to draw it in so I can sort of see what it looks like. So that's that diagonal going that way. And you write the rule down. xy goes to yx. So we're just going to turn around the different values. But be careful. So it's 4, -4. So when you turn them around, the -4 that was the y is now the x. And then the 4 that was the x is now the y. B was 8, -3. So change the order. It's -3, 8. And C, which is 10, -5, just change the order. And then we just graph these. Let's pick another color here for y equals -x. For that, the mapping is you are going to change the order, but you're also going to take opposite values. For this one, let's see what happens. We have 4, -4. If you change the order, we've already done that. That's over here. And now I'm going to take the opposite values. So that goes to 4, -4. So perhaps the easiest way to handle this is to just look at my y equals x coordinates and just take the opposite values. Like I said, you need to be careful, and I always kind of look when I'm done. Does it even make sense? So this is going over y equals negative x. That's right, that line going that way. If you were to fold along this line here, each of these points in the black triangle would line up with that beige-looking triangle. And then finally, we're doing a point reflection. That's what this means, A, B, C in the origin. Point reflections, everything stays in the same order, but you just take the opposite values, so negative x, negative y. My A prime, I'm just going to look at my negative 2, 6 and just make them opposites. B prime will be opposites, and C prime will be opposites. And I was just looking up here to see what the point values were and just taking opposite signs. So we'll graph the pre-image first. Let's graph our reflection points. Now, we are expecting this to look upside down, so we'll see what we get here. And we do. We get an upside down version of that. And that's basically all we have for reflections. So I hope this was helpful for you, and thank you for watching.